Hey guys, so here's the notes for 3.5. We're going to be graphing radical functions. Okay, so let's first talk about the square root parent function. Well, the square root parent function is going to be as y equals square root of x. Okay. So when we are thinking about this, we are going to plot points into x. So we are going to create an xy table, just like we've done before. Okay. Now we have to think, what numbers work going into the square root. Well, we've talked a lot about with domain, right? Knowing that positive and 0, those values work with even roots, and the square root's even. And we plugged in a negative number, right? That would give us an imaginary solution. And we can't graph that on our normal XY coordinate plane, okay? So when you're plugging in numbers, whenever you have a square root, there are going to be certain numbers you're going to plug into there, and then with cube roots, the same thing. Okay, well, we know we can't have negative numbers, so then let's think about the smallest x value we can plug in. Well, that's going to be 0, right? Okay, well, let's think of some other numbers. Now, remember, because we're taking the square root, we don't really want to get decimals. We want to get nice numbers. So maybe thinking about, okay, what are perfect squares that are positive? Well, the next number is 1. So don't forget, 1 is a perfect square. And what's probably the next one? 4, and probably 9, right? We could do 16, but that's going to go off the graph, okay? So we want to plug in positive perfect squares because that allows us to get nice numbers out. Okay, we take the square root of 0, that's just 0. If we plug square root of 1, we get 1. Square root of 4 is 2, and then square root of 9 is 3. Okay, so now let's go ahead and plot this. So we are at 0, 0, then 1, 1, then 4, 2, and then 9, 3. Okay. And then we connect all the points and then have an arrow. Okay. So notice this is more of a ray. So we have a starting point and then we keep going on. Now it's not a straight line. Okay. So similar to a ray, but not quite, because here we have a little curve. Because remember, we talked about the inverses of y equals x squared. So with our quadratic, remember, if we graph that entire thing, then we would have this bottom part as well to graph. But this would make it a function. So that's why we only graph part of our square root of x there. Okay? Okay. Now let's talk about domain and range, because we will have to talk about that later. Now we've talked a lot actually about domain with the square root or with even roots. And we've done it without having the graph. But at least this is a nice visual to know, okay, what would be the domain? So remember, domain is our x values, right, or the horizontal. Know that we do start at 0, and notice that we continue on to the positive direction, okay? And so since 0 is included, we use a bracket, and we go to positive infinity. Now, range we really haven't talked about too much, okay? Well, once again, let's kind of look. So remember, that's our y's. Well, notice that our smallest or lowest y is 0, and then our y goes to positive infinity. And 0 is included. There you go. So you're kind of really starting off when you're doing domain and range from what we call the critical point. So our critical point is 0, 0, because that's our starting point. And then what you have to do is kind of look at, okay, what's happening with our x's? Well, they're going to positive infinity. And what's going to y's? That's the same thing. Okay, now let's go ahead and talk about the cube root parent function. So the cube root parent function is y equals cube root of x. Now, once again, we're going to do the same thing. So in order to graph, we need to create an xy table, okay? And think about what numbers work with cube roots. Well, remember, we talked about this as well when we talked about domain, right? Well, we talked about positive numbers. When we plug it into x, we get real numbers. 0 works. And negative numbers work. Because remember, you can take the cube root of a negative number. Okay, so we know we can choose any negative, 0, and positive. But now let's think about, well, what numbers do we want to plug in so we get, integers back out instead of having decimals and fractions? Well, we want perfect cubes, right? So let's think about, and let's go to the negative. What would be our first negative perfect cube? Well, that's going to be -8. Now, if you need to, you might want to write out your perfect cubes. We have 1, 8, 27. But of course, we don't want to go too big because we are graphing and we don't really have like 27 on our graph. Okay, will be our next one. It will be -1. 0 always works. Then we have 1 and 8. So here we'll have 5 numbers that we can plug in. Okay, so let me write that. We want all perfect cubes. There you go. Okay, so now plugging in it, what's the cube root of -8? That should give us -2. Cube root of -1 is just -1. So remember, because we can think of -2 times -2 times -2, that does give us a negative, so that's why it works. Cube root of 0 is just 0. Cube root of 1 is 1, and then cube root of 8 is 2. So notice we get the same numbers, but it's just the signs that are different. Okay, let's go ahead and plot this. So if I go over to -8, I go down -2, and then I have -1, 1, 0, and then I have 1, 1, and then 8, 2. There you go. Okay. And as I said, it kind of looks like a snake, right? And we talked about what this looks like when we did the inverses. Okay, now let's talk about domain and range. Now we kind of actually talked a little bit about domain and range of these cube roots because when we did the inverse of a cubed function, we talked about domain and range. Okay, domain, notice that all the x values are being included. So that's going to go from -infinity to +infinity. That's going to be the same thing for range. So this is slowly going to build, but it is going to hit all the y values. So we go from -infinity to +infinity. Okay? Okay, make sure you watch the second part of this video. That's where we're going to be working with more of these cube roots and square roots.